sorry. Exercise 8D, quadratic models. So last lesson we had a look at quadratic functions. Okay, so quadratic functions are the nonlinear graph of graphing a quadratic equation being an equation with the highest power of 2. So if the highest power of 2 is in an equation, what it will graph is a parabola. Okay, so either a happy parabola or a sad parabola, and depending on how, I guess, complicated the equation is, if anything's added to it and things like that, it will move where its vertex is. But a general parabola of y equals x squared will have its turning point or its vertex at the origin. If it's positive, obviously it's above the x-axis. If it's negative, it'll be below the x-axis. So this lesson we're having a look at quadratic functions again, but this time we're applying it to quadratic models. So just having a look here. It says quadratic modelling occurs when a practical situation is described mathematically using a quadratic function. Now, I have mentioned before that these model exercises are more related to what you would get in a HSC question. Okay, they're probably not going to ask you just to graph a parabola for no reason. They're going to ask you to graph a parabola and then solve some further questions from it. So these every second exercise is, I guess, extra important. But you can't really do it unless you've done the previous one. Alright, so a quadratic model describes a practical situation using a function in the form of y equals ax squared plus bx plus c. So that's your standard form of any parabola, where a, b, and c are numbers. Quadratic functions are graphed to make a curve in the shape of a parabola. Okay? And now, you are never expected to graph one without a table of values, so you don't really need to worry about transformations. Alright, now today's first example is very common. I've seen it come up a fair few times, and I'll add up some HSC questions that will be related to this one. So the area of a rectangular garden of length x meters is given by a equals 6x minus x squared. So first we're going to fill in that table of values. So you can just throw that straight into a calculator. So if you have x as 0, you will get 0 because it'll multiply out, and then I'll just quickly fill these in. But that's really easy calculator work, and you should see some sort of flip around because it is a parabola. So you can see it gets to 9 as a peak and then it turns back down. So part A is to draw the graph of y equals 6x minus x squared using the table of ordered pairs, which is that table of values. Now I have set up an axis to save a little bit of time. So along the bottom is my x. Here is an A. So A is representing area of a garden. Okay. So A is the area, whereas X is the length in meters that are the dimensions of this rectangular garden. Okay, so that's area. I'll just write that. So length. Alright, so we've got 0, 0. We've got 1 and 5. We have 2 and 8, 3 and 9, and then we flip back over, go 4 and 8, 5 and 5, and 6 and 0. So if I draw, it's a bit of a sad looking parabola, but I guess you get the point. Now it's in the first quadrant because you can't have negative area. Okay, now what this represents is if the length of the rectangular was based on whatever the length is, what the area would be. Okay, so having a look at the second question where we apply that. Right, B, use the graph to estimate the area of the garden when the length of the garden is 4.5 meters. So meaning 4.5 by 4.5, I guess. Just grab a highlighter. So 4.5 is here. So you want to draw all the way up until your graph hits, well, your line hits the parabola. Is it straight? Yep. I don't really love my parabola here, but according to my graph, the area would be 7. Now, I don't actually think. Let me just check something very quickly because my parabola is a bit lopsided. Yeah, that's fine. Okay. Now, what I was checking is I just wanted to check it in the calculator to see if 7 was the right answer. Now remember, it's reading off your graph. So even if my parabola is drawn a little bit lopsided, because I've read my values, 7 meters squared is fine to say for that total area. Okay, but they will accept a range. They might say we're going to accept anything between 6.5 and 7.5 because it all depends on how they've drawn their lines. Okay. So the graph estimates area of the garden to be 7 meters squared. Okay. Now, part C, what is the maximum area of the garden? Okay, so that would be that maximum point. So the maximum area that you can have of this garden is 9 meters squared. And that would be if you did it as a 3, length of 3. What is a garden length in order to, just answer that question, to have the maximum area? The maximum, the garden length would have to be 3 meters. Okay, that's that one. Alright, stopping distance. So we looked at this in the year 11 course, back when we were doing, around the time we were doing the assignment about driving. Okay, so stopping distance is the distance a vehicle travels from the time the driver sees an event occurring to the time the vehicle is brought to a stop. It is calculated by adding the reaction distance and the braking distance. So if you're driving a car and you see a dog run out in front of you, that time from when you saw the dog to when the car comes to a complete stop is the reaction distance. And as it says there, it's a combination of the reaction distance and the braking distance. Reaction distance being thinking distance, so it's the distance travelled by the vehicle when a driver decides to brake to when the driver first commences braking. Reaction time averages 0.75 seconds for a fit and alert driver. That's very quick. Braking distance is affected by the road surface, slope of the road, weight of the vehicle, and condition of the brakes. Okay? Alright, so the formula for stopping distance is reaction distance plus braking distance. So reaction distance is given by that formula. Braking distance is given by that formula. Now, they would always be given to you within the question, so it's just a matter of application. Alright, so Talia was driving at a speed of 60 kilometers an hour and a reaction time of 0.80 seconds. Calculate the stopping distance using the formula. So distance equals 5. Now V is the velocity or speed of the motor vehicle, so that would be 60. T is the time of the reaction, so 0.80 in that question. And that gets divided by 18 each time. Plus, now V we spoke about is the speed, so that's 60 squared divided by, and it's always 170. So all that just goes straight in the calculator. So the distance is 34.508, blah, blah, blah. Oh, sorry, 5098. Now, it wants to answer correct to the nearest whole meter, so that would be approximately 35 meters for that person to come to a complete stop. Okay. So have a go at that exercise and hopefully you don't have too many problems.